Hey folks, so welcome back to our next Algebra 2 lesson. Today we're going to be going over solving quadratics, and we've done some of this before in Algebra 1, and we've gotten close to it in Algebra 2 with our factoring, but today we're just going to throw it all together into one big lesson, then we're good to go. So without any further ado, let's take a look at solving quadratics.
So let's get to it. We're going to be solving quadratic equations with integral roots today. Now, integral is referring to positive or negative whole numbers. None of our answers today will have fractions. And our steps are, get the equation to standard form. Remember, standard form is equal to 0 and decreasing exponents. Then we want to factor as much as possible, and this is using what we've been practicing over the last couple of lessons. And then set each factor with a variable equal to 0, and then solve it out. Okay, if it doesn't have a variable, you don't need to set it equal to 0. Let's see. So we got our steps up here, just in case you want to see them. And here we go. Let's do this first one. So it's already in standard form. You can tell because it goes exponent of 2, exponent of 1, no exponent, and it's set equal to 0. So therefore, already in standard form, that first part's done. Factor as much as possible. Well, then we need to identify how to factor it. This is a factor in sums. So I need factors of 3 that add up to 4. Well, there's just 1 and 4. 3 is a positive, but 4 is negative. So that means these both need to be negative. All right. So I'm going to have x minus 1, x minus 3, oh, that should be a 3, sorry, equals 0. We factor as much as possible, yay! Now we need to set each factor, remember, this is a factor, this is a second factor, equal to 0 by itself. And that's because of the zero product property. Two things are multiplying together and they equal 0, either one could be 0. And then we just need to solve. Well, in this first one, I'll add 1 to both sides. And the second one, I'll add 3 to both sides. And we're done. We solved. We're good to go. You could check it by graphing this in standard form. Just change this to a y. And seeing where the roots cross the x-axis. We'll check that out in a minute. Now,
All right, so we're going to test this out right now. In our previous one, we found x squared minus 4x plus 3 equals 0, comes down to x equals 1 and x equals 3. Let's test it out. I'm going to plug this original equation in, and I'm going to do it equal to y. That's what it is over here. And then where it crosses the x-axis, right here, that's at x equals 1. Right here, it's where x equals 3. That's the exact stuff that we found here, x equals 1, x equals 3. So, nice, easy way to check to know if you're right. Just plug it into Desmos or any other graphing calculator, and you're good to go.
now these clearly look a bit different. We can call this the first one. We can call this the second one. Neither one of these are in standard form. We need to get them to be standard form, which means decreasing exponent order and equal to 0. Well, let's just do it out. This we can distribute. We'll get x squared plus 7x minus 2 equals 28. Then we just need to move the 28 over to the other side. So we'll get x squared plus 7x, subtract the 28 from both sides, we get negative 30 equals 0. So now that first one, we've gotten it in standard form. Here on out, we just need to check factors of negative 30 that add up to positive 7. So we got 30, 1, 30, 2, 15, 3, 10. That 7's a positive, so it means the bigger number has to be positive, the smaller has to be negative. The pair that will do it is this. So let's write it out. We got x minus 3, x plus 10 equals 0. And you'll start to notice that once we set each one of these equal to 0, the sign will kind of just flip on us. And you might remember that from previous math classes as well. So those are our two answers. And again, we can graph out the standard form. We can graph this out and set that equal to y. And the 3 and the negative 10 are where the parabola will cross the x-axis. Let's take a look at the second one. Second one looks even funkier. We got a lot of stuff we can move over. So let's start just moving it over. We have 3x squared. I'll move the 2 over. So it's going to be negative 3x minus 36. I just use some inverse operations to move stuff over. Well, here I have a GCF that I can take out first. All of these terms have a 3 in them. So I can do now we can factor out this middle one by saying factors of negative 12 that add up to, remember this is a negative 1. That 12 is a negative, so it means that one of these is going to have to be positive, one's going to have to be negative. And this 1, this negative 1, means the bigger number has to be negative. We got 1 and 12 with a negative 12. We got 2 and 6, negative 6. We got 3 and negative 4. Well, the one that's going to give us a difference of negative 1, right here. So we'll get 3, don't forget to bring it down, x plus 3, x minus 4. So I wasn't checking off. We got it to standard form, we factored as much as possible, and now we need to set each factor with a variable equal to 0. Now, we don't need to set this 3 equal to 0. It doesn't have a variable. I mean, there's no way that this 3 could ever be set equal to 0. It's 3, not 0. So we don't need to worry about it. We can just set the x plus 3 equal to 0, the x minus 4 equal to 0, and solve. We'll end up with x equals negative 3, x equals positive 4. Cool. Now, everyone's favorite part of math, the word problems. Bow, 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 bow. Now, the first one, Brad is 3 years older than Francis. The product of their ages is 154. Determine their ages. So, Brad is 3 years older than Francis. Let's call Francis x. If Brad is 3 years older, then this is just going to be x plus 3. Well, the product of their ages is 154, so that means I can just say x plus 3 times x equals 154. And from here on out, it's just solving the same way that we did. Distribute x squared plus 3x equals 154. Get it to standard form. And then we just need to find factors of 154, which multiply to negative 154 and add up to 3. The factors that are going to do it are going to be 11 and 14. So we're going to have x minus 11, x plus 14 equals 0. So that means that x equals positive 11, x equals negative 14, because we just set them each equal to 0 and solve. So this next one, the length of a rectangle is 6 feet less. So length is 6 feet less than 3 times the width. The area of a rectangle is 144 square feet. Find the dimension of the rectangle. So you might be saying, oh my goodness, this looks awful. What are we going to do? Well, if the length is reliant on the width, I can call the width x. So I'm going to be multiplying by x at some point. Now, what's in red? The length. The length of the rectangle is 6 feet less than 3 times the width. So we're going to have 3x minus 6. And it's going to be equal to 144. Cool, so let's simplify this stuff a little bit. Get it into standard form. And now, what I can ask is if there's a GCF. There is, it's 3. Okay. Then I just need to split it up. I need to ask myself what are 2 factors of negative 46 that are going to add up to negative 2. Silly me. That's 48. You astute viewers probably saw that at home. Then we're going to ask ourselves what multiplies to 48 and then adds up to -2, and that's going to be 6 and 8. So 8 is going to be negative, 6 is going to be positive. Now remember, we don't need to set the 3 equal to 0, because there's no way 3 could equal 0. We just need to set everything else equal to 0. Alright.
So you've seen how to solve, you've seen how to check to make sure you're solved, you've seen how to do it in standard form, you've seen all that. Time to head on over to Delta Math. For Delta Math, your first problem set is just putting stuff in standard form. That's it. You're not solving, you're just putting in standard form. You got 5 questions of that. Afterwards, you are solving. You got 10 questions of that. You can do it. I know you can. After that, you have word problems. You only got 3 because you just did those 10 questions, and okay, that's a lot. So, give it a shot. If you have any questions, ask away in the Zoom call, because you're of course watching this during class when you're scheduled to. Right. And then, you can also come to office hours if you have some more questions. Have a great day, folks. I look forward to hearing from you, and stay safe.